Record. Share screen. Boom. Today, oh, here we go. Here it is. This is official. Today is 1/3. I'm just going to write the year 24. I think that's my first time actually writing it down. 1/3/24. Exciting. This has come up and I've addressed it in passing. I feel like though it deserves a day to get its fair place in your notes. And this is called officially the counting principle. I've been trying to just kind of skirt around this, and every time it's come up, I just kind of informally hit it. And then I thought that's probably not, in fairness to you, the right thing to do. So let's just take a day, because then to the next assignment tomorrow, I think maybe Monday, but probably tomorrow is going to involve you reading a problem and telling me, is it a permutations problem, a combinations problem, or a counting principle problem? And that's not really a fair ask if we don't spend a little time talking about what is this counting principle. So the counting principle, it's kind of hard to define. So we'll kind of define it by just saying like, this is how you use it. This came up when I was talking to, I think it was Diedrich, when he's not here, but when we were talking about like Subway sandwiches. So let's say you walked into a sandwich shop and it was a very basic shop. Like you're not allowed to go and like add extra things. And let's say that you were going to make a sandwich and there were 5 kinds of bread. And then they had 4 different types of meat. And then they had 3 different types of cheese. This can become a more complex situation if we start saying like, well, I can do like multiple meats or like multiple cheeses. To keep this counting principle stuff just on the simple level for now, if I were going to go in there and make a sandwich where I'm allowed to use 1 type of bread, 1 type of meat, and 1 type of cheese, the counting principle says this, that you take basically the number of things along the way and you multiply them together. So when I set up a problem like this, and we'll be doing this a lot in the next 10 minutes, I set it up as, okay, here's a blank for the number of breads I can choose from. Here's a blank for the number of meats. And here's a blank for the number of cheeses. The counting principle says if you want to know the total number of ways to accomplish a task, then you have to multiply all of the ways to accomplish each little subtask along the way. So for breads, I simply place a 5. For the meats, I say, well, I've got 4 of those to choose from. And for the cheese, I say, well, I've got 3 of those. And I want to say this for probably now the 3rd time, maybe the 4th. These are multiplications. And so you'll always place time signs in between your little stops when you're doing the counting principle. So it could be a sandwich shop. It could just be at home in the kitchen, whatever. But if you are going to build a sandwich with this many choices along the way, how many different sandwiches could you make? The answer is 60, right? And that, think about it, that might be like rye bread, ham, cheddar, rye bread, ham, pepper jack, rye bread, ham, whatever, American. And then so you start thinking about all the possible different sandwiches you can make, and it happens, you're like, wow, that's a lot of sandwiches. So that's in its basic form what the counting principle says to do is line out the number of stops along the way that you're going to make, and then multiply the number of possibilities at each stop like that. Now they get quite a bit more complex. So let's talk about your lockers out there in the hall. You guys, side note, if you're like me, you probably don't even go to your locker most of the time. I don't even think I knew where my locker was my senior year of high school. Just carried around a backpack, right? But do you guys know that on your dials, I believe your dials have the numbers 0 through, what do they go up to? Do you know?
40. Can I go look?
Yeah, would you go take a peek real quick? I'll pause the recording while you go look. I want to say it's 39. So your lockers out there in the hall go from 0 to 49.
Why not 50? Just make it.
Because the 0 accounts for the 50th spot. So first things first, how many numbers are on one of your dials? There are not 49.
Like the total?
There are 50 total. And the thing about this will come up kind of again and again and again, is that when you count a set of numbers, if it starts with the number 0, you actually have to add one at the end. Like if you were to put up your fingers right now and count to 4, but start with 0, you go 0, 1, 2, 3, 4. You're like, what the heck? I counted to 4, but I have 5 fingers up. 0 always adds 1 to your total, right? So there are actually 50 numbers on one of your dials out there, and that would change from school to school. Some schools might have like 0 to 39 or 0 to whatever, but yours have 0 to 49. So let's think about like how many possible locker combinations are there for you guys? Let's say you forget your combo, right? And so you're like, gosh, I'll probably guess it before too long, right? So this is going to be my pro tip to you. So if you stopped listening, you should come back to me now and focus and listen to this. Every problem you do for the counting principle should be set up as, let me draw blanks for every action that I have to do. How many actions are there when you open a lock on a locker? I believe there's 3, right? There's like a first number is an action, the second number is an action, and then I think there's 3 numbers in your combos, right? I think, but that doesn't really count because you can't really quantify that. So like when we talk about like how many actions, we say there's a first action, that's the first number, and then your second, and then your third. So when I set this problem up, I'm going to set up a blank for the first number in my combo, a blank for the second number in my combo, and a blank for the third number in my combo. And then I'm going to, if you want to, while you're at it, just put time signs in between them just while you're thinking of it. If you do it this way, I'm not saying that today's assignment is going to be easy, but it's going to be a million times easier if you start like this. Now, how many possible numbers are there for the first number of your combination? There are. And do you guys happen to know, does anyone in this room have a locker combination with 2 of the same numbers in it, like 36, 18, 36? Is that a thing? Can your numbers repeat? So in that case, then basically it's going to be all along the way. There's 50 possible things the first number can be. How many are there for the second? And how many for the third? Right. Now, if they said, like at the main office, that, hey, Tim, when you go and change all the locker combinations this summer, let's not have any with the same numbers ever happen twice, then your list would dwindle, right? You'd say I have 50, then I've only got 49 left, and then I've only got 48. Because when things can't repeat, they can't be used again, right? They get taken out of the mix. So what is 50 times 50 times 50? 125,000. So that means on just a nice little simple dial like yours that go from 0 to 49, there are 125,000 possible locker combinations. Got it? So far, so good? Okay, I'm just trying to run through kind of the topics that you're going to see throughout your assignment. I won't probably hit them all, but I'm going to try to get like the big ones. So let's talk about license plates. So let's just make up in some state. Let's say that a license plate is like 2 letters followed by 3 digits. So I don't know what this is. I did research one of them and it's accurate. There's one about Alaska on your homework and I did make sure that it was actually accurate. But this, I don't know maybe there's a state that has it this way. Maybe there's not. I don't really care for the purpose of this. But an example of a license plate, what I mean by that is that you might be driving down the road in some state and you look at someone's license plate from that state and it might be like KR044 or something like that. Do you see what I'm? Alaska is 3 and 3, correct? Yes. That's a good memory you've got there, bud. Oh, all right then. Good. I want to move to Alaska someday. Like in Cheyenne, do you guys know what the Cheyenne, the Laramie County or the Wyoming?
I think it's, Goshen County 7. Just 7?
I mean, like,
Yeah, we're 2. Yeah, and
no, I mean, I'm sorry. I know we're 2 county. I just meant what's the structure of our license plates?
I think it's 30. Wait, I have a picture of the license for it.
And what's the rest?
Whatever.
Is it? So anyways, let's figure out if you lived in this state, how many different license plates are possible. So that's going to be a very common theme. When we talk about the counting principle, I'm not going to ask you questions like probability today. I'm not going to ask you questions like permutation, combination. I'm just going to say, how many ways can this happen? So, if Trinity moves to this state and she goes and gets her vehicle registered down at their Department of Motor Vehicles, or not that, but the government building or whatever, the courthouse, yeah, then she might think, okay, well, how many different license plates could I walk out of this place with? Well, here's what we do. We set it up. We say, here's the license plate. First, second, third, fourth, fifth. And again, I'm drawing 5 blanks because if you go and look at the license plate, there are 1, 2, 3, 4, 5 characters in the license code, correct? Okay, so here we go. And let's say for the sake of this particular problem that things cannot repeat. So the example that I have here is actually not going to work. It would have to be like KR048 or something like that. So let's say that characters in this particular state, for whatever reason, you cannot have the same number or the same letter twice on your license. So here we go. In the first blank, what's there going to be? A 26, because there are 26 letters in the alphabet, A through Z. How many things are possible in the second blank? Good job, guys. 25, because we can't use the same one as we used before. Now we head on to the digits portion of it. 10. Yeah, again, it's this misconception. We think of 0 through 9 and we think there's 9. But remember, what I said is if 0 counts as a digit, then 0 through 9 is actually 10. By the way, it's where the word digits came from, is from our fingers. That's why your fingers are called digits. Have you ever heard that before? Yeah, like Mr. Cooper would tell you, watch out, you're going to lose a digit on the table saw. Like, there's a reason our number system has 10 digits, and we sometimes call our fingers our digits. And so, so there are 10 possible digits, but then since I can't repeat, then it's going to go times 9 times 8. And then we're going to type that into a calculator. Yeah, so this would be a smaller state because there's not enough license plates to go around. So this one would be 468,000. You might think that's a big number, but imagine like in California. They need a lot of license plates in California, right? Or Texas. Right, yeah, right, exactly. So that's the general structure of how this works. Any questions so far? Okay, let's do how many 5-digit numbers are there? Let's not put a stipulation on this. Let's just do this one just as is. And you might think the answer is obvious, like, well, duh, of course, but it's sometimes less obvious than we think. So what's going to be step 1 if I'm building a 5-digit number?
The first number.
What's the setup to this? Nope, no math yet. What's the setup? Just draw your blanks. Very good. Thank you for that. So remember, before I even talk about 10s and 9s and 8s and stuff, I'm just going to say, this is my 5-digit number right here. If you don't do this, you are going to struggle mightily with this assignment and the next one. So since it's a 5-digit number, I need 5 blanks, and I'm going to put time signs in between the blanks. Now, no stipulation was given as to whether or not numbers could repeat. So if anyone ever forgets to say, just assume that it's not a rule. You can repeat if you want to. So you ready? Careful. Why did you say 9?
10.
I don't want an answer. You should know this about me by now, Mike. I don't want the final answer. How many numbers can go here? Okay, so here's an example of a 5-digit number, right? 24,321. Here's another example of a 5-digit number, 94,002. Here's another one, 16,825. You get the idea? So let me come back to my question. If I'm building a 5-digit number from left to right, how many digits can go in this first blank? See, now that's the best thing I've heard yet. The answer generally people would say 10 because there's 10 digits, but Aiden over here crushed it. He said 9. If I had you write a 5-digit number, would you agree that like 0, 4, 3, 8, 9 is not a 5-digit number?
No.
Can a 5-digit number start with 0? No, because then it's not a 5-digit number anymore, right? So we assume that there are only 9 digits that the first one can be. Now, what could the second one be? 10. How about the next one? How about the next one? How about the next one? Very good. Got it? So then you would multiply all those together, and that is 90,000. So there are 90,000 possible 5-digit numbers. Good, good. Whether or not things can repeat is kind of a big recurring theme as you go through this. How about this one? How about a multiple choice? So let's say that you're going to take, let's say you take a test in Mr. Allen's class, and the first 10 questions are true, false. And then the last 8 questions are multiple choice, where each question in the multiple choice has 4 possible answers. So you can see the structure of the test. It has 18 questions. The first 10 are true, false. The last 8 are multiple choice. And so if I'm going to make the structure of my test, I'm going to need to build 18 blanks, right? Which is going to get pretty obnoxious in this case. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to draw my 8 multiple choices. 1, 2, 3, 4, 5, 6, 7, 8. And there are shortcuts to this, obviously. On a true-false questions, how many ways can you answer that question? 2. So every one of these first 10 blanks is going to be 2, 2, 2, 2, 2, 2, 2, 2, 2, and 2. Now on the last part, the multiple choices, how many ways can you answer each of those? Good job. So we're going to have 4 possibilities, so on down the line like this. So if you think about it, like if you came into this test like completely unprepared, had no idea what was going on, and you were shooting for a really good grade, as you're going to see here in a moment, your chances really aren't very good, right? Hey, what's a shorter way to type this that I'm underlining in purple into your calculator? Nice job. So this could be typed in as 2 to the power of 10. And then what's a shorter way to type in what I'm underlining in green? Nice job. So use your exponents when you can. It's going to save you some time. So I'm going to type that into my calculator. 2 to the 10th times, of course, 4 to the 8th. That's a lot. So the answer came out to 6, 7, 1, 0, 8, 8, 6, 4. Which means that just on an 18-question test like that, there's over 67 million ways to submit that test. So again, if you go in and guess, your chances aren't very good of having that end well for you. Well, yeah, this will be a challenging assignment for you guys, but I tried to provide you with what I think is good structure. If you have questions, I will help you, but I would like you to do me a favor and not ask for my help until you have drawn all of the blanks necessary. So if it says like, hey, it's going to be a 7-digit passcode, then don't even read the rest of the problem. Just go 1, 2, 3, 4, 5, 6, 7. And then you and I can talk about if you get stuck, where are you stuck? But I feel like you need to do that first and then fill in the blanks as you go. But it'll be a little bit of a struggle. Maybe not. I don't know. So I would say, are there any questions? But I'm going to leave the recording going so that as you have questions, then I'll just unpause and answer your questions. Correct. So let's check up if you're already working on problem one. So in problem one, basically I draw like a little wall right here. You don't have to do this. This just helps me to kind of break it down into its pieces. So I know, bless you, to the left of the wall is digits and to the right of the wall is letters. So if I'm building a passcode, I have 10 possible things that the first digit could be. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. But because it says that anything can be repeated, then I have 10 choices again, and then I have 10 choices again. Good. Now we're on to the alphabet. Now the rest are letters, and there are 26 letters in the English alphabet. So I have 26 options for my first letter. How many options do I have for my second letter? What about my third? What about my fourth? Good. So anyways, you're going to multiply all this out on a calculator. So that
Is
is,
this supposed to be that big?
it should be a huge number. I got 456 million.
Yeah.
And by the way, I'm going to show you something about numbers here, and I'm going to talk to you because eventually you're going to take a quiz on this, and I would encourage you to not test the waters on this. So here's what my calculator says. And I'm telling you this because I'm sending you out either to your senior year or for some of you out into the world. That number, if you present that to someone, is utter garbage. You should agree because it doesn't make sense. Like the human mind does not read a number like that and know what it is, right? We do it in chunks. So what the brain does is it needs those commas. This isn't a Mr. Ahern thing. This is just a common decency thing. So when I chunk commas, I do not want to start from the left because like I might, let's say I guess and I go, oh, maybe there's a comma there. And then, and then I'm like, oh, well, that doesn't make sense. You always comma chunk from the back, from the right. And so I chunk by threes. I go chunk of 3, chunk of 3. And now the number is easily understandable as 456,976,000. Got it? Any number that is 5 digits or longer requires the use of a comma. 4 is kind of one of those. Some people do it, some people don't. Let's take a look at question number 2. Again, what am I going to start by doing? I'm going to draw 7 blanks because it's, again, a 7-character passcode. So here's my passcode. There it is, right there. And this time, when I chunk it, not chunk it, but when I divvy it, I'm going to divvy it a different way. Because this time it says 2 digits followed by 5 letters. So I can draw my little line like right here. Right? And this time it says characters cannot be repeated. So, you know, how many options do I have right out of the gate? Yeah, this first one can be whatever the heck I want it to be. How many choices do I have for the second one? 9 now. Because I can't repeat whatever I picked. It's not 10 again, it's down to 9. Because whatever the first one was I picked for my code, I can't use it again. I don't know what it is, but I don't care. It's just one less that I have to choose from now. Now let's get on to the alphabet. How many letters do I have to choose from? What about the second one? Good. So again, that structure is the key. When you go into it and you know how long your answer is going to be, draw out the blanks and then just common sense. This isn't something I can give you a formula for, or just like, hey, can you just show me how to do this? You just got to think every time you think, how many possibilities are there in the blanks? And this one's pretty big. So let's see, that's 90 times 26 times 25 times 20. Yeah, so this one is big. So this one is 710,424,000. Hey, let me ask you a question. Common sense. Why does this one have so many more possibilities than the first one? More letters. And there's more letters to choose from than numbers. So that's why. Yeah. So I'm gonna repause. Just keep going. Like problem 3 is an utter joke, right? Like that's easy. That's just a little calculator problem. I'm gonna repause. Let me know if you guys need more or have more questions. What is a prime number?
It can only be times by itself.
Right, a prime number is a number that has exactly two factors. I put caps lock on my pen there for the word exactly because let me put the numbers, here are the numbers on a die. 1, 2, 3, 4, 5, and 6. So let's talk about yeah. Thank you. So if we follow the textbook definition of what it means to be a prime number, is 1 a prime number?
Yeah.
It is not. And the reason I'm talking to you right now is really just to get that point across to you. It's one of the most common misconceptions is people say 1 is a prime number. But if you go up here and look at this word that I've underlined for you, exactly, what are the factors of 1?
1.
That is right. 1 only has 1 factor himself. What are the factors of 2? 1 times 2 are the factors. What are the factors of 3? 1 times 3. What are the factors of 4? 1 times 4 or 2 times 2, right? What are the factors of 5? 1 times 5. And what are the factors of 6? 1 times 6, and of course, 2 times 3. So if you go by the textbook definition of what it means to be a prime number, and I'm saying this again to make a point, you have to have exactly 2 factors. How many of the numbers up on the board can you say have exactly 2 factors listed underneath them? That one is a prime. That one is a prime. And that one is a prime. Here's the way it works. 1 is nothing. 1 is neither prime nor composite. But once you start at the number 2, every number, every whole number past that is either what we call a prime or a composite. If you have more than 2 factors, then you're said to be composite. So like 4 is a composite. 6 is a composite. What is 11? Prime. What is 15? Composite, because you can make it other ways, like instead of 1 times 15. So when we talk about rolling a die, like problem number 9, when you roll a die, there's 6 things that can happen, right? How many of them are primes? 3. If I roll a die and the number 2 shows up on top, so if I get a 2 like that, if the die looks like this, then I say I rolled a prime, right? Or if I roll a die and it looks like this, then I got a prime, correct? Or if I roll a die and I get this, then I got a prime. We clear? So that's what a prime number is, and that'll come up again. So make sure you know that 1 is not a prime. People often / almost always think that 1 is a prime. 1's not a prime. He's a weird number, real trashy kind of, but not a prime. Good.